In our video today, we're going to cover story problems that have linear inequalities showing up in them. So what we're going to do is a lot of stuff fairly similar to the 3.3 material, and that process is specifically in that we're going to read, reread, underline, and mark up the different problems and paragraphs that we are given. I don't necessarily think these problems require that you set up buckets or tables as you're going through them to get to the final answer, but you absolutely could make those in any way that makes sense to you. We'll do that with a couple problems, but a lot of this really just comes down to figuring out a way to organize the information you've been given and then see how it all relates to one another. This specific difference that we have between our previous sections and now is that instead of having an equal sign showing up in our problem, we are going to have an inequality symbol showing up. So that's our greater than or equal to, less than, and less than or equal to symbol showing up here. So one of the things that a lot of people like to do, I don't think there's anything wrong with it, it just does require that you do one step afterwards, is start with creating a standard equation. Something equals something else. We have an equal sign showing up in there. And then go one line below that and rewrite everything as an inequality. Which side of the equal sign should be greater than, less than, greater than or equal to, less than or equal to the other. Now, all of that determination there at the very end with which inequality to use has to be told to you somewhere in the problem that you are working with. So there's a lot of different buzzwords and ways that they can have that written in there. Some of them are pretty clear and obvious. Others are not so much. We need to read through it a couple times. So take the time you need to as you're reading through them to determine which specific inequality symbol we are using. We can also make some reasonable assumptions based on the wording of a problem to determine which one we're using as well. So let's dive into our 4 examples that we have here. If this thing will let me scroll, there it goes. So we have these 4 examples. Let's go ahead and dive into those and take a look at each one of them. Our first example tells us that Tom is loading a pallet with boxes that each weigh 45 pounds. The pallet can safely support no more than 900 pounds. How many boxes can Tom safely load onto the pallet? Now there's a few ways we can go through and write this out, but let's look for some buzzwords and some things that are standing out to us in this story problem. We're told the pallet can safely support no more than 900 pounds. This right here would be our set of buzzwords to let us know, hey, we need to be, or we can be at most a certain amount. We can't go over that. So this is our cue showing up right here and our hint that we're going to have an inequality in here. And we're told specifically it can't hold 900 pounds with that. Okay, fantastic. We're also told some information about the boxes. Each of the boxes weighs 45 pounds, okay? And we're being asked how many boxes can Tom safely load onto the pallet. Okay, cool. So a number of boxes, each weighing 45 pounds, and I need to make sure that I don't exceed this 900 pound limit. So a few different ways you could organize this and think on it for yourself. I think a really good one is to start in very broad general terms and then build more specifics into that as we go through and kind of organize our information a bit more. So we think of it like this. We have 2 sides of an equation. We'll start with an equation for now. So let's say we have on one side, this is the box, weight. Come on, I had to get a little, there we go. So the box weight. And we have that equal to, what would be on the other side that we could potentially be using? The, let's say the pallet weight. Let's revise this just a little bit. Instead of pallet weight, let's do pallet support weight. Because it can only support so much. That seems a little bit better, a little more specific there. Cool. So currently, as I have it set up, the box weight would equal the pallet support weight. Now, are we looking for this weight to be equal, or are we looking at maybe something with an inequality showing up? So we're going to have an inequality here. So we could revise this from being an equal sign to say, would it make sense to have this be a less than sign, a greater than sign, less than or equal to, greater than or equal to sign in here? And we could think of this. Do we want the box weight to be less than the pallet support weight? Do we want it to be greater? And think of it like that. So with what this problem is describing, we're told the pallet can support no more than 900 pounds. So that to me suggests that we want the box weight to be either less than or equal to. But the problem doesn't indicate that it can't be 900 pounds. It says no more than 900 pounds. So that to me suggests that we're going to have this less than or equal to showing up. So the box weight needs to be less than or equal to the pallet support weight. And that seems reasonable given everything in the problem so far. So let's go ahead and rewrite this so we know that the box weight should be less than or equal to the pallet weight. We can erase some of these guys here. Maybe. Okay, there it goes. All right, let's do that. Okay, so let's start filling in some information about the box weight and then the pallet support weight. Well, we know that this support weight is only going to be 900 pounds. So I'm just going to go ahead and write in 900 over here. What do I know about the box weight? Well, each box weighs 45 pounds. I'm asked how many boxes can Tom safely load onto the pallet, so I don't know the number of boxes, but I could determine the total box weight if I did know that. I could take the number of boxes, let's say that is B, and I would multiply each box by 45 pounds to give me the total box weight here. And suddenly I have an inequality written out, and I can go through and I can solve this thing. If I divide both sides of this equation by 45, then I'm going to be getting, doing this calculation off screen, okay, I should be getting 20 out of this. So the number of boxes, B, should be less than or equal to 20. So Tom could load 20 boxes at most onto this pallet, or any of these pallets in this problem. For example 2, we are told Tara's phone plan costs her $28.80 a month plus 20 cents per text message. How many text messages can she use and keep her monthly bill no more than $50? Okay, so again, we have an inequality that's going to be showing up here. We're told that we want to have the bill be no more than $50. Sometimes this is also written out as keep her bill at a maximum of $50 or not to exceed $50 or something to that effect there. So we can also go through and we'll use a slightly different strategy and setup than we did in our previous problem to get to the same result, but just to see some different ways that we could think on these things. So we are told that her plan costs $28 a month plus 20 cents per text message. So what we could do is maybe we make a quick write out here for ourselves. She has all information regarding costs written out here. So we know that she's paying $28.80 a month. So it's probably the monthly charge there. And then she's being charged 20 cents per text. So we can write that in too. Cents per text. It doesn't need to be the whole thing written out, but a quick bullet point goes a long way with this. So cool, so we know she has a monthly charge and she has a per text charge. And we want, let's see, her monthly bill to be no more than that. Okay, so on the other side with this, let's make one with what else is going on over here. So you could call this maybe restrictions or goals or requirements or something like that. We want her monthly bill to be no more than $50. Okay, So we can kind of see, even with how we have it written out here, we have part of our information or part of our inequality, and then the other part of our inequality, costs and our want. Or maybe you write this in instead of a want, you could have it as a goal, something like that also. Your choice on how you want to organize and label these, but I think either a want or a goal would work on this side. So let's start actually building an equation here out of this. Well, what's the cost going to end up looking like if I were to write this out as some sort of an equation? And again, we'll start with an equal sign and we'll revise it in a line down below here. So what are her costs looking like? Well, it's this $28.80 per month, and then she's being charged 20 cents per text. So it's this $28.80 plus 20 cents per, I'm going to use T to represent texts. You could use X, you could use N, you could use whatever you would like to. But I don't know how many texts are being sent in this 1 month. And that makes sense because we are looking to try and find out how many texts can keep the bill under $50. So that being an unknown, that makes sense. That aligns with what we're doing. Awesome. Now what do we have on the other side? Well, we want the bill to be no more than $50, so we have just the $50 over here. The way it's currently set up is we would have the costs equal to $50. Well, the problem is telling us that we want to keep the bill at no more than $50. So we need to revise this into an inequality. And again, that's going to be either greater than, less than, greater than or equal to, less than or equal to. And these labels that we had here are really helpful with this. Do I want the costs to be greater than the goal, or I want it to be less than? Do I want it to be greater than or equal to, or less than or equal to? Can I be at $50 and still meet my goal, or can I not be at $50? Do I have to be below it, or do I have to be above it? And this looks like we want to keep the bill to no more than $50. And again, that sounds like it's going to be an instance where we can include 50 as a potential total cost. Okay, so we're going to have one of these bottom two scenarios here. Do I want the cost to be greater than or equal to 50, or less than or equal to 50? And I'm probably going to choose this less than or equal to 50. That makes sense. We don't want the costs to exceed something. So in the line right below this, let's revise it one last time. We get $28.80 plus 20t is less than or equal to 50. And that seems to make a lot of sense with what this problem was telling us. Now let's go through and let's solve this thing for t. So what we've found, based on working through this inequality, that Tara can send at most 106 text messages for this month. Taking a look at example 3, we are told Jennifer has a pet sitting business. She charges $32 per hour. Her monthly expenses are $2,272. How many hours must she work to earn a profit of at least $800 per month? Now again, we have a fair amount of stuff going on in this problem. I think it's a pretty good call to organize this for ourselves before we start making equations or inequalities as necessary. So I'm going to make some bullet points here. We have something regarding $32 per hour. We have something with $2,272, and then we have $800 per month. Makes a little bit better underline. There we go. So what do we know about each of these numbers? Because they all relate in some way, shape, and form. Well, she charges $32 per hour, so we could think of this, nothing else, maybe make a quick bullet point on it. Oops, actually put our title in here first. Let's say income and expenses, because we were told that part of this is money she has coming in because she's charging a certain amount, charging $32 per hour, and then we're told her monthly expenses are this $2,272. So we could think of this as she's making money. She makes $32 per hour. That could be the income. Maybe you put a little plus here. Maybe you put it at the very end. Maybe you just have something for income. And then we have an expenses one. This is this 2,272. This would work against her. So you could use this as maybe a negative sign. Maybe you have a completely different column over here that's just listing expenses. It's your call. I'm just going to list this as a minus right here. So she's going to be losing $2,272 in expenses. We don't know what those are. Maybe it's one big thing. Maybe it's a compilation of these 5, 10, 20 different things. Who knows? But we know her expenses are $2,272. Fantastic. So we can also ask then, okay, well, how many hours must she work to earn a profit of at least $800 per month? Okay, so we could also have a part in here, do what we did in our previous problem. Let's say we have our goal. We want $800 in profit. Okay, so that means we want to have a positive amount of money at the very end, and that's exactly what our amount is, what we're aiming for. Obviously, based on the way it's phrasing, profit of at least $800 tells us that this would be great, but if we could make more than that, that would be even better. So we'll keep that in mind when we're working with our inequality part here in the middle in a second. But let's start making an equation out of this. So the income and expenses, she's earning $32 per hour. So let's make that as 32, and we'll use H to represent hours. Now, with the expenses, is that adding to the amount that she's getting, or is that taking away? And it would make sense for it to take away because it is listed as expenses, after all, in the problem. Okay, so there's the income expenses working out and interacting, and we want that to be equal to 800. And again, we're going to revise this here to an inequality, but we just make our initial equation just for starters. Now, would it make sense to have greater than, less than, greater than or equal to, or less than or equal to for this problem? Well, we're told she wants the profit of at least $800. So that to me sounds like it's going to be this greater than or equal to. If she makes $800 a month, fantastic, she's met her goal. If she had $1,000 per month or $8,000 per month, that would still meet the goal, and you know what? That'd be great if you're making $8,000 profit per month. So I feel like we would take that one. So let's go ahead and scroll down here. Let's rewrite this equation into an inequality. And now, from here, we can solve this thing for H. So based on this, we know that she needs to work at least 97 hours per month or more to earn an $800 profit. And here we are at our fourth and final example. So we are told that Eric wants to go on a 10-day road trip next spring. It will cost him $180 for gas, $450 for food, and $49 per day for a hotel. He has $520 in savings and can earn $30 per driveway shoveling snow. How many driveways at minimum must Eric shovel to have enough money to afford the trip? Now we've got some similarities between this problem and example 3, where we have some amount of money coming in or money that he's earned, and then we have costs showing up as well, or expenses, another way you can think on this too. The difference is we are not exactly told what the direct and specific outcome is that we're looking for. We know that we want to be able to have enough money to afford the trip, but we don't know, and the problem hasn't told us exactly or directly what that amount is. We need to figure out what numbers could be useful in helping us figure that out. So my recommendation is let's set up two columns for ourselves, one representing income and money that we've earned, and the other one representing costs or expenses. Now I'm going to use green underlines to represent income, and I'm going to use red underlines to represent costs and expenses as we go through our paragraph of stuff up here. So first and foremost, we're told it will cost $180 for gas, $450 for food, and $49 per day for a hotel. So let's go ahead and underline those as our expenses. If you're going through and doing these problems for yourself, I think it's very handy to use a little bit of color coding as you're writing these out. And now we have all of our costs and expenses listed right over here. Let's go through and see what money he has in income or money that he could potentially earn in this problem. So we're told he has $520 in savings. Okay, well, it's not really income that he has, like he's earning the money, but it's just money that's just already there, sitting there waiting for him to use. We can kind of count that as income if nothing else. And then he earns $30 per driveway shoveling snow. Okay, that's definitely money that he has coming in and earned income there. So let's go ahead and list these two out. All right, now that we have all of our income and earned money listed here, we have all of our costs and expenses listed here, we can start seeing how we could relate this material together. There's one part that is written over here in our costs and expenses that we don't have entirely figured out, so we're going to actually do that really quick here. And that has to do with our hotel costs. We are told that he's charging, or he's going to be charged, $49 per day. Well, do we know what that total amount is? Well, if we just focus in on the $49 per day part, no, it's not clear. However, elsewhere in the problem, we have the necessary information to find the answer to that. We're told he wants to go on a 10-day road trip. So, 10-day road trip, $49 per day, I can do a quick calculation here and determine what that total is. So it's going to actually cost him $490 for that hotel. Okay, fantastic. Now let's go ahead and, based on what we've been given here and how we've organized this, let's list out everything for the income in dollars here and have that equal to our costs and expenses listed here. So now we have the last part here because we have it listed as an equation right now. We want to rewrite it into an inequality, greater than, less than, greater than or equal to sign, less than or equal to sign there. So we'll list those here just to figure that out. And now, which one of these are we going to use? We're told and asked, how many driveways at minimum must Eric shovel to have enough money to afford the trip? The at minimum is our giveaway here that we are going to have an inequality and a little bit of a hint at which ones we're going to be using. So it sounds like we're trying to have this income be at the very least equal to the expenses. But if this income is greater than that, we'd probably also be happy with that as well. So that's going to be where we're going to use this greater than or equal to inequality. So we'll take one step to rewrite this thing. And now we can actually go through and just solve this thing for the number of driveways that Eric's going to need to shovel. So based on this, we know that Eric needs to shovel at least 20 driveways to offset his costs and expenses. Bringing things back together at the very end of the 3.6 video here, We went through our story problems with linear inequalities, and we went through our different processes that we could use to create these inequalities and solve them for ourselves. All of the processes that we did use today to write out and underline important information or make lists of important information, all of that can be used in any of these problems and any of the problems that you might experience on the homework or in your particular classes. I think reading through these things, which is similar to the process in 3.3 and 3.1 also, is very, very important. So that way you know, is this number going to work in this way with the problem or in a different way with the problem? Is this number adding with something else or is it subtracting with something else? And along with that, making sure we're reading carefully for the buzzwords that will indicate if we're going to have a greater than or equal to, less than, or less than or equal to inequality showing up in these problems. We also went through setting up all, or I think a fair amount of these, using a standard equation and then rewriting them into inequalities. You do have the choice if you want to, just to jump right into writing these things out as inequalities and skip this equation step. I merely wanted to highlight that this is an option that some people like to use as they're going through and setting these things up, but you're more than willing to skip that, or welcome to skip that, I should say, and go right to inequality forms here. So that will do it for our story problems with linear inequalities.